Hello everyone, welcome to St. Lawrence Science Digital Library. I am Ranjita. Metals can either corrode or remain stable based on their reactivity. Metals are considered reactive if they easily lose electrons when they come in contact with other substances such as water or acids. In today's module, let us learn more about the reactivity of metals. The reactivity of metals refers to their tendency to undergo chemical reactions. It is particularly with oxygen, water, and acid. So, now let us see how metals react with oxygen. Children, when metals react with oxygen, they form metal oxides. So, the word equation for this is metal plus oxygen gives metal oxide. Now, do you think all metals react in a similar way with oxygen? No, right? So different metals have their different reactivity. Now, the reactivity of metals, children, it depends on their position in the reactivity series. What is this reactivity series? When we talk about it means it's an arrangement of metals according to their reactivity. Okay? The metals that are topmost in the series are most reactive metals like potassium and sodium. Okay? As the metals go down the series, they are less reactive. Got it, children? So, now depending on this reactivity series, we see the reaction of metals with different elements. Now, here we have oxygen. So when metals react with oxygen, they form different types of metal oxides. Now let us see how zinc reacts with oxygen. Children, when zinc is exposed to oxygen, as it is shown in the picture, it forms zinc oxide. And the chemical equation for this is Zn plus O2 gives ZnO. Okay? So now what is this zinc oxide? Zinc oxide is a white powdery substance, children, which forms a protective layer on the surface of the zinc. Okay? And this makes it more corrosion resistant, which means it protects zinc from corrosion. Okay? So now let us see another example, that is iron. So when iron reacts with oxygen in the presence of moisture, children, it forms iron oxide. Iron oxide is also commonly called as rust. Okay? Now it is usually reddish brown oxide that is formed on the surface of the iron substances. Okay? When the iron substances come in contact with oxygen and moisture or water, this iron oxide is formed. Clear? Now this rust, children, it causes iron to become weak. Okay? So to prevent this, we can use different methods like oiling, greasing or painting. Okay? Now the next example is copper. Copper, children, when it reacts with oxygen, it forms black copper oxide. This layer is called as patina. What is it called? It is called as patina. Okay? Now this patina, it acts like a protective layer which prevents the copper from further corrosion, and it also increases its durability. Okay? So now this also increases the durability of copper. Clear? Now, the last example for metals reacting with oxygen is gold. So, what do you think, children? How will gold react with oxygen? You would have seen and also worn different gold ornaments, right? Children, gold is a noble metal. What does it mean? It means that it is resistant to corrosion and it does not react with oxygen. Okay? It does not react with oxygen even at very high temperatures. Got it? That's why it is called as noble metal. So, because of this property, gold does not get tarnished or neither gets rusted, children, even when it is exposed to air. Okay? So, gold has very high value and it is also expensive. Got it? So, now gold it is used for various purposes like to make ornaments and it is also used as currency. Got it? So, I hope you have understood about the metals and how they react with oxygen, right? And when coming to the reactivity series of gold, children, it is placed at the bottom of the series, okay, as it is least reactive to any kind of elements. Okay, so clear about it? Now let us see how metals react with water. The reaction of metals with water, it also depends on the reactivity, children. I told in the previous slide, right? So the reaction of metals depends on its reactivity series. Now, highly reactive metals, they react vigorously with water and they produce metal hydroxides and hydrogen gas. So metals react with water to form metal hydroxides and release hydrogen gas. So we can write the word equation as metal plus water gives metal oxide plus hydrogen gas. Clear about it? Now, let us see how potassium reacts with water. So when we consider potassium, children, it's known for its extreme reactivity with water. You can see there in the video there, as soon as potassium is added into the water, what's happening? Yes, it's catching fire. So it is so reactive that it can catch fire. So what's happening here? Why is it catching fire now? It's because the reaction is highly exothermic, okay, where heat is produced and hydrogen gas is also liberated, okay. So the released hydrogen gas that is spontaneously catching fire here, okay. So now this is leading to a flame, children. So therefore we can say potassium, when it is introduced to water, children, it not only forms its hydroxide, that is potassium hydroxide, but it also generates heat and ignites the liberated hydrogen gas, which results in a fiery reaction. Clear? So now this is the characteristic of potassium metal, okay, that it can catch fire when it comes in contact with water. Clear, children? Next we have calcium. So let's see how calcium reacts with water. Observe the picture there. Observe the video there. So as soon as they add calcium into the water, what's happening here? So it is reacting with water, but is it as vigorous as potassium? You can compare both, children. No, right? But it is still reactive. So what's forming over there? So the calcium that reacts with water and it forms calcium hydroxide. Okay. Now this calcium hydroxide, it makes the solution alkaline. Okay. So now it doesn't catch fire like how it happened in the potassium case, but you can see their white color, right? Effervescence. It forms an effervescence due to the evolution of hydrogen gas. So here also hydrogen gas has been released. Okay, understood about the reaction of potassium and calcium in water? Is it clear? Yes. Now let's see another example. We have Sodium. So how does sodium react with water? So sodium, children, you can see there, as we add sodium into the water, it floats. Can you observe? It's floating. Now why is it floating? So now when we recall the concept of the which kind of objects float and which kind of objects sink in water. So we can recall that concept, children, and we know that objects that are like lighter, right? That means which has lower density than water floats on water, right? And objects that have more density than water sinks in water, right? The same concept we can apply over here. Due to the lower density, okay, due to sodium having a lower density compared to water, it floats in water, okay. So when sodium reacts with water, it produces sodium hydroxide and it releases hydrogen gas, okay. And now whatever the hydrogen gas is liberated, it may ignite, causing a flame. See, you can see there, it's causing a flame, right? So it might ignite, causing a flame, and it is also highly reactive as potassium we saw in the previous slide, right? So the ability of the sodium to float on water, it reflects that it is having lower density than water. Clear? Now let us see how does magnesium react with water. So when we see magnesium, observe, children, as soon as we add magnesium into the water, it sinks, right? It is sinking. That means magnesium is more denser than water. It has more density than water. That is why it is sinking, right? But sodium was less denser than water. That's why it was floating, okay? So now magnesium, it reacts with water and it forms its respective magnesium oxide and it also releases hydrogen gas. Okay. Now hydrogen gas is also released during this reaction. Now hydrogen gas, you can see the bubbles being, the bubbles are visible, which tells us the hydrogen gas being liberated. And magnesium hydroxide, it's a white insoluble solid, children. Insoluble white, it's white, okay. Now insoluble solid that can be observed as a precipitate. Clear? So now this is about how the metals react with water. Is it clear about it? Children, now next let's learn how metals react with acids. Metals can react with acids to form metal salts and hydrogen gas. So metals react to form their respective metal chloride. Okay. So now let's see with an example here. When we take zinc, okay. So now zinc, it reacts with dilute sulfuric acid. So what happens when it reacts with dilute sulfuric acid? It forms its respective chloride and it releases hydrogen gas. Okay. So what happens, children, as hydrogen gas is produced, it will get accumulated. Okay, now in this test tube you can see we are adding zinc granule over here and sulfuric acid, that is dilute sulfuric acid, has been taken. So as soon as they add the zinc granule, you can see the reaction has started, right? You can see the bubbles being released over there. So that bubbles, that is producing hydrogen gas, okay? So that gets accumulated in this space above the reaction mixture in the test tube, okay. So now when it is getting accumulated, to test this, children, when we flame when we introduce a flame, okay, when we introduce a flame, because of this hydrogen gas that has got accumulated, it rapidly explodes. A small explosion takes place. Explode means it's not in a bigger way. A small explosion takes place, because of which you can hear a pop sound, okay. So when you get a pop sound, it proves that hydrogen gas has been released. Okay, clear about it? Now I hope you have understood in this module how different metals react with oxygen, water and acids, right? Thank you.